All right. So I guess that's the maximum count of participants that we can have right now. So let us start now. So are you guys now ready?
Yes, sir.
Okay, so before we'll start, do you guys have a question or any concern regarding with our past module?
None,
Question,
sir.
guys, or any concern
None, sir.
regarding with your quiz, your exercise, or assignment, or with our
None,
lecture?
sir.
None, sir.
Okay, so since there are still others who are taking the quizzes and exercises, so I will discuss or we will discuss your activities from the module 1 next meeting, which will be next week Tuesday. Okay? So sa mga may mali, chill muna kayo. So you will know on Tuesday what are the parts that you made a mistake. All right. So for the week 2, okay, so supposedly we will discuss this one last meeting, okay, Kirchhoff's current and voltage laws. But something happened, something came up, so we wasn't able to meet on that time. Okay, so we'll be late for one meeting. So later on, or yeah, maybe not later. Next meeting, okay, we'll be having two topics at the same time. Okay, so don't you guys worry. Once you're done with Kirchhoff's law, learning about Maxwell is a lot more easier. Okay, so they're actually super similar. It's just that they have their own specifications. Okay, but quite similar, like 70% similar. All right. So for this week, okay, this second week, we will only discuss Kirchhoff's current and voltage laws, and then next meeting we'll discuss Maxwell loop, and then maybe superposition. So those two topics next meeting. So for now, KCL and KVL for now. All right. So are we clear with that, guys? Hello.
Yes, sir.
All right then.
Yes,
So
sir.
I hope that okay. So I hope that you guys have already visited this one. Though I have added another one. Okay. So the same topic learning outcomes from last meeting, the same list of topics, but I've just added one video, okay, on what is the difference among node, junction, branches, loop, and mesh. Okay, especially the loop and mesh. So they are those two are quite tricky, but you will know later on once you have watched this 6-minute video. Okay, so this number 4. And then the same reading materials and then same references. Okay, so please do check those video materials, reading materials, and then references. Okay, so those video and then those reading materials will 100% help you, in terms of solving difficult circuits. Okay, so the one that we're going to discuss for today are, of course, the basics only. But if you want to have more complicated circuits, so feel free to visit the this website, electronic tutorials, even this 2 PDF or ebook. Okay, so this will definitely help you, okay, to gain more techniques, more skills on how to solve complicated circuits. All right, so enough with the overview of your week 2. And then, of course, here's the PDF. So you can download this one right now so that you can have your own copy while we're having our discussion. And I've prepared one practice activity, okay, which is 40 points, and then 2 website, okay, which just simple questions, like you have this one is multiple choice. So we'll just warm up your knowledge in terms of solving about KCL and KVL. So if it's blocking or if the canvas is blocking the website, just click this one. Okay? So it will lead you to its website. So maybe this website has something to do with security. I don't know, with the canvas. So yeah, so it is something like this, wherein you have a very simple circuit, and then you can answer this one by using A, B, C, D, etc., etc. Okay. So you can also check if your answer is correct or no. And then the other one is for, oops, I guess they are the same. Yeah. The other one is, I guess it's blocking some of the features. It's just loading really long. So in here, actually you're going to answer this one on your own. Okay, so you're going to be given a circuit and of course some values of it. And then it will ask you to solve for blah 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 and so on and so forth. And you can check the answer right. Where is that one? I guess I have to go to its main website. It's blocking some of the features. Where is that one? Here. So click here to see the solutions. So from there, let's say you have already answered the 1, 2, 3, 4, and 5. So here's where you can check whether your answer is correct or not. Okay. So yeah, these are just some basic examples when it comes to KCL and KVL. So I hope that you guys will visit this one, okay, just in case you need more examples. So yes, that's it for the practices exercises. And then I have already prepared here the quizzes. So supposedly, we are now discussing the mesh, okay? But then again, since something came last meeting, so you're only going to take Kirchhoff's law quiz. Okay, so next meeting, you're going to take this one, Maxwell quiz. So for now, just answer this one right after our discussion. So I will publish this one, and then you may now start in answering this one. So take note the due date of this one is until March 12th. So you guys have 1 week to prepare for this one. So be sure to visit or take the practice exercises first before going to the quizzes. All right. And of course, I have also prepared a case study. Well, this one is super simple. Well, in fact, this is not a case study. This is like more on sharing. Okay. So learning on how to analyze and solve a circuit diagram to know the voltages, currents, power, etc. is a little bit difficult, especially if it's your first time in solving such things. So uh, maybe in some circuits it's very easy, but in some cases there are students or people, even though it's super easy already, like it's very straightforward, they are having a hard time in solving the voltages, currents, power, individual resistance, etc., etc. Okay, so I would like you guys to help your classmate, or I would like you to help your each other. I would like you to help your ano ba? I would like you guys to help each other. Yon, yung gusto kong sabihin. Okay? In learning on how to solve or, have some or gain some techniques or tips on how to solve for voltages, if it's series, if it's parallel, if it's a complicated circuit, etc., etc. Okay? So, yeah. Aside from resources that your instructor gave you in this subject, what are things that you do to enhance more of your knowledge in terms of electrical circuits? So where do you practice or on what specific website you visit to learn more knowledge and techniques? Okay, so I've added a note here. Supposedly there is a word note here. So I would like this discussion as a sharing of knowledge, tips, techniques in solving circuit problems. Okay, so with this way, you'll be able to help your classmates to improve their skills in analyzing or solving circuit problems. Okay, so you can attach a link if you want. Like for example, I always go to this website when it comes to this kind of problem. I visit this YouTube link when it comes to this problem. Okay, so you can also attach a YouTube link. Okay, so yeah, that's it for your case study or discussion. Okay, number 2. So are we clear with this one, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So help your classmates too. Okay, so some of you, let's say 30%, yeah, 30% of you are already good when it comes to solving circuit problems, but there are others who are really not good. Okay, not really 0%, but at least 10 to 20%. Okay? They are having a hard time. So I would like you guys to help one another. All right. So yeah, I guess that's for the overview of your module two. Module three. Since module one and two is already in week one, so module three is the Kirchhoff's current voltage law. Anyway, so let us now start with our main discussion for today. So as you guys will know, we're going to talk about Kirchhoff's law. Okay, so let's just have a short walkthrough. So yeah, we've learned already on how to calculate voltage, current, resistance, etc., using Ohm's law. But there are some complex circuits where they cannot be analyzed using Ohm's law. Okay, so that is why we have this Kirchhoff's circuit law to solve such complicated circuits. Like for example, we have this bridge resistor circuit wherein it's not solvable by using Ohm's law alone. Okay, so the same with T networks, you cannot solve this one using Ohm's law only. Okay, so that is why we have this Kirchhoff's circuit law. Okay, so who invented or who came up with this idea, Kirchhoff's circuit law? Okay, so it is actually from this German physicist. So at the year 1845, so Gustav Kirchhoff developed a pair or set of rules or laws which deal with the conservation of current and energy within electrical circuits. Okay, so his idea mainly came from this highlighted sentence right here: conservation of current and energy within electrical circuits. So he believes that, in every loop or in every node, everything is equal to zero. Okay, like if we have a force coming from the left, there is a force that is, of course, will come and collide with each other, and then it will be reflected, and then like nothing's happened, like it will be neutralized by both sides. So that's what he believes when it comes to the flow of current. So if there is a start, there is an end, something like that. Okay, so these two rules are commonly known as Kirchhoff's circuit laws, where it's divided into two. Okay, so we have the KCL, or Kirchhoff's current law, for the current, and then we have the Kirchhoff's voltage law for the voltage, or KVL. Okay, so what is this KCL and KVL that we are talking about? So first, let's talk about KCL. So later on, we'll discuss what is KVL. But for now, let's talk about KCL. So this is the first law. Okay, so the current law, or KCL. So KCL states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave. Okay, like for example, if you enter to a certain door, then you're definitely going to leave the other door. Like for example, you entered to a certain room, of course you'll end up uh, going inside of that room. Like there is no such magic, okay, when it comes to electricity. So if there is an entrance, there is also an exit. Okay, it could be that there is an entrance, but there is no exit. Okay, so basically like that. And yeah, so in other words, the algebraic sum of all the currents entering and leaving a node must be equal to zero. Okay, like I current that is exiting plus I, or the current that is entering, is equal to zero. Or if you're going to transpose this one on the other side, so exit is equal to negative entering. Okay, wherein you could see that they are equal, but just a different call this one polarity, or different sign. Okay, so this idea by Kirchhoff is commonly known as the conservation of charge. So we have this example here, wherein this one right here, the one that is in the middle, which has a blue one. Okay, this one is called node. Okay, so let's say in a node there are some currents which enter this node, and then there are also some currents which goes out or leaves this node. So we have 3 currents that is going in and then 2 currents that is going out. Okay, so in KCL, if it's entering, we're going to put a sign which is positive. Okay, so positive I1, positive I2, and then positive I3. But once the current leaves, then that is now the time that it's will have a negative sign, or yeah, since it's now leaving. Okay, so positive for entering and the negative sign for leaving. So that is why we have negative I5 and then negative I sub 4. All right, so if it's entering, it's positive. If it's leaving, it's negative. And then, of course, equate everything to, or equal everything to 0. All right. So basically, this is the one that you have to memorize when it comes to KCL. So entering the node positive, leaving the node negative. All right. So here are the 3 currents, and actually this is just the explanation. Okay. So I leave this part to you. So we can write this one into something like this, which is similar with this one. Okay, so again, if it's entering the node, it's positive, and then if it's leaving, it's negative. So later on, we're going to have an example with a real circuit wherein there are currents entering and then there are currents leaving that circuit, okay, or that node. Okay, so what are those nodes that we are talking about? So as you guys can see right here, we have this node right here, node right here, node, 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 node. Okay. So you could say that they are the edges or the junction wherein in every or it connects from this path to this path. Okay, so it's a connection between 2 paths. So we have this path from your voltage source, and then we have this another path from your resistance. So between that, we have a node. Okay, so the same with this one. So we have a node here because we have a path here wherein it's across R1, and then we have another path here which across R2. Okay, so as you guys can see, the node's like separating 2 components. Okay, or it's like, yeah, a separator, but mostly it's like a junction. Okay, that connects 2 components. R1 and R2 is connected with each other, and R2 and your voltage source is connected with each other. R3 and your current source is connected with each other, etc., etc. Okay, so those are our nodes. And we have here the second law, which is the KVL. Okay, so in here, this one is much more simpler actually. All you need to do is follow the given signage or given polarity. So Kirchhoff's voltage law or KVL states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop. Okay, like your VRs or voltage drops in a series circuit. Okay, so let's say you have 3 components or 3 resistors wherein you can get the individual voltage drop on each of those components. And if you're going to sum up all of those, it will be equal to your voltage source. So the same idea with this one. Okay, so all of the voltages that is flowing on each of the components will be summed up once it reach the starting point of the loop. Okay, so of course, once you have already have everything, let's say VAB, VBC, VCD, VDA, you also have to equate that one to 0 or equal it to 0. Okay, so in other words, algebraic sum of all voltages within the loop must be equal to 0. So this idea by Kirchhoff shown as the conservation of energy. All right. So those are the 2 principles when it comes to Kirchhoff's law. So we have the KCL, wherein if it's entering the node, it's positive, and then if it's leaving, it's negative. And then if it's KVL, the sum of all the voltage drops around the loop is equal to 0. Okay, or let's say it's equal to the total voltage or voltage source. All right. So can you guys follow up to this point? No, guys.
Yes, sir.
Yes, sir.
Okay, so again, if there are parts that is quite unclear, so please let me know. So take note that I do not discuss everything anymore since I'm expecting that, or I expected that you guys have already made an advanced reading. Okay, so the one that I'm only discussing right now are uh, the things that you might have missed, maybe, or the summary of this PDF or this module, right? So yeah, again, this is just a loop wherein you can have a clockwise or a counterclockwise way of loop. So either of those two, it's correct. Okay, so you can use uh, any polarity. So if it's clockwise, then use clockwise. If it's counterclockwise, then use counterclockwise. Okay, so the only important thing when you've started counterclockwise, then stick with it. So the same with clockwise, you must also stick with it. Okay, so that is why I've highlighted this one, same direction. Okay, so don't you guys worry if your answer is negative. You only assume the incorrect uh, flow of current. But if your answer is positive, then the assumption of flow of current in that circuit is correct. Okay. So all you do is if you've got a negative result, then just make it positive. Okay. So it's okay. Either of those two. Okay. And what else? All right. So before jumping into having an example or real examples when it comes to Kirchhoff's laws, so there are terminologies that we have to uh, learn or know before jumping or diving into uh, answering such circuit. Like for example, this one, the node, which we have already discussed. Then we have here the path. Okay, so later on we'll have the definition of each of those terminologies. So we also have here branches. We also have here loops and then meshes. So what are those terminologies? But before that, okay, let's discuss these two types of flow of current first. So if you've decided to choose the clockwise, so this one is called the conventional current. Okay. But if you've decided to choose the counterclockwise, this one is called the electron current. Okay. So in my case, I always use the conventional current, okay, because that's where I think most of the current flows. So it's like, in my case, 80% on solving problems, it's always conventional current, especially if the voltage source is on the left side. Okay, I've never saw a current where it's flowing from bottom and then going to the right. It's always from upper going to the right and then going down and then going back to its original place. Though, of course, there are some cases wherein it will start down below and then will go to the right and then go back to the left and then go back to its original position. But mostly it's conventional flow of current. Okay. So this one is called the electron current because it's connected with negative. That's why it's called electron current. Okay. So as you guys may all know, when you see electron, it's negative ions. All right. So yeah, either of those two, you won't uh, get wrong. So yeah, it's completely up to you. So you can choose any of those flow of current. And here are the definitions of the terminologies that we have just read a while ago, right here. So circuit is the word is one. So circuit is a closed loop conducting path in which an electrical current flows. So no problem with this one. And path is a single line of connecting elements or sources. Like for example, this one. This is a path. This is another path, another path, another path, another path, another path. So basically, it's just a line. Okay, a single line. And we have here the node, where in each of those line, okay, where we have this 90-degree junction or 90-degree angle. So most probably this one is one node already. So you could, you can label this one as your node A, node B, node C, and then node D. So in here we have 4 nodes. Okay. So a node is sometimes called a junction. That is a connection between two paths. Okay, or just a connection or a terminal. Okay, within a circuit where 2 or more circuit elements are connected or joined together. Okay, so giving connection point between 2 or more branches, a node is indicated by a dot. All right, and then we have this branch. Okay, so you could say that branch and path is the same with each other. It's just that when we say branch, okay, it has a component inside of it. Okay, so it could be a source or it could be a resistor, could be a capacitor, etc. As long as it has a component inside it. Okay, and one more thing, when we say branch, it's mostly 2 nodes connected with each other. Okay, like for example, uh, let's just say that there is a resistor on this part. So this is one node and then another node. That entire path or single line path, that's one branch already. Okay, and then this is another branch, another branch. Okay, however, if let's say we don't have a component in here, okay, we don't, it's just a single line. Okay, we could not say that this is a branch. Okay, because a branch is most likely has a component between it or across it. Okay, so if it's just a line, then that is not a branch, just a single line, right? Or just a path. And a loop is a simple closed path, okay, in a circuit wherein no circuit element or node is encountered more than once. And then a mesh is a single closed loop series path that does not contain any other paths. So we don't have enough time anymore, so we will continue the loop and mesh on the part 2. All right. So goodbye for now and see you guys on part 2.
Bye,
Bye,
sir.
sir.
Goodbye.